Blue. We are going to be talking about harnessing AI agents for faster and more accurate, reliable software testing. And I just have a couple of housekeeping points that I want to just make before we move on. We're going to be recording this session, so I hope everyone is happy with that, but we do need to make it available for replay. So there's a recording in session right now. We're also going to be live streaming on YouTube. So I'd like to say thank you and welcome to everyone that's joining us on YouTube. Yeah, we don't have any emergency exits, so let's just crack on. So my name is Zoe Laycock. I'm the lead of product marketing here at DiffBlue. And I'd also like to introduce my colleague, Animesh, who is joining us today. Is taking a little bit of a backseat, but is certainly going to be contributing to the session. Animesh.
Hello, I'm a software engineer by training, and I've been working as a solution engineer for the last 5 years, mostly helping enterprise customers adopt emerging technology, make sense of what actually works and what's just a lot of hype. So I'm looking forward to the discussion.
Thanks, Animesh. And I was formerly a full stack application developer, so I have some technical knowledge. Somewhere along the line, I took a wrong turn into marketing because I like to launch and drive adoption of products. So I've worked in the time travel debugging space, API management space, and for a number of companies that are offering tooling that assists developers in different parts of the software development lifecycle. In terms of what we're going to talk about today, we're going to be running through the following. So we're going to take a little look at the productivity potential of AI-driven development. This is an area where there's loads of buzzwords, loads of jargon, and there's a lot of really out there claims about products. But we're going to try and demystify some of that. We're going to look at the current use of AI across the software development lifecycle. We'll take a little look at AI assistants versus AI agents to shine a torch on some of the key differences there. And then we're going to loop back and we're going to relate that to what is needed and what are the essential requirements for actually scaling AI-driven testing and development to the next level. We'll give you a very quick overview of DiffBlue Cover. We're not going to do a full demo today, but we are going to tell you a little bit about DiffBlue Cover, and then we'll take some Q&A from you all, because we'd really like to hear your thoughts as well. And before I just crack on, I'd just like to draw your attention to the AI for Code survey. You should all be able to see it presented by Zoom now. We'd really appreciate your feedback on that. We'd like to hear what tooling you're using, what you're using it for, and actually how much confidence you have in the AI products that you're using. And we'll come back to that. So please do fill out the survey if you're able to, and we'll see what you're all using, and we'll bring that into the session. So if we start with our use of AI for code, what is the actual productivity potential? Why are we actually using AI at all? Well, it's because the reality of software development, regardless of whether you're an engineer or whether you're a test QA person, wherever you are in the software development lifecycle, you know, a lot of us, particularly in development, are, writing code. But our sort of work processes and our daily reality looks somewhat like this. Writing code and massive amounts of time spent testing and debugging that code. And really, one of the challenges is that we spend a lot of time on code validation, and we don't really have time to actually really devote our full energy to the ongoing development, to do the best that we can on each project that we have. And then also sometimes, we are context switching. That is the reality of modern software engineering. And so it's kind of like, you know, we're spending a lot of time on repeatable tasks that take a lot of time and effort. So that's one of the reasons why we're all looking to AI, right? We're looking at the productivity potential. We're looking to AI to actually try and break that cycle to enable us developers to do more of what we're actually good at, what we want to do, which is writing code and architecting applications, high value tasks. And what you can see here on the loop is that essentially we want to spend more time writing that code and making sure it's the best code that's going to build great experiences and applications. But we want to use automation more. If we use automation, the productivity potential of AI-driven automation is potentially that we will have more free time to do high-value tasks that actually require the input of a human developer, and maybe a little less of the stuff that we don't particularly want to do, which is time-consuming and repeatable. So that's kind of the productivity potential of AI and what we're looking to. We're really looking to AI to actually reduce developer toil. And if we're taking a look at what toil looks like, it's very much tasks that we have to do that are related to programming, but are very manual traditionally, highly repetitive, have potential to be automated, and you know, don't actually scale very well. They scale linearly. So if, for example, we are spending lots of time testing and debugging, and there is a drive to continuously test, the only way to test more with manual and traditional processes is to actually add more time, devote more time to that, to test continuously, potentially add more heads in terms of the numbers of developers or the amount of developer time that's actually spent testing. So it doesn't scale very well at all. And if we look at where we're at today and how we're using AI, the DORA State of DevOps 2024 report really validates this by actually showing where we're spending our time using AI assistance predominantly. And as you can see, you know, a lot of it is about code creation. We've got 75% of developers who are using AI for code writing and code creation, 60% of developers that are using AI for testing, and approximately 56% of developers that are using AI for some of those tasks we've just mentioned that are repetitive and very, very time consuming. Other key areas include code explanation, trying to understand the code more, documentation is related to that. So a lot of this is how we use AI coding assistance today. And more than ever before, coding assistants are producing more and generating more code. And in 2024, the Stack Overflow survey, respondents, 63% of them actually fed back and said that they are using AI in the development process. And one of the big stats, one of the big data points of last year that was slightly surprising in its scale was that Google was responsible for reporting to the market that 25% of all new code generated at that business was generated by AI. But what we do need to note is that that code, though it was generated by AI assistants, it was then reviewed and accepted by engineers. So there was still a manual element to the process for Google. And AI isn't just being used in the development part of the SDLC. What we're trying to show here is essentially it's way more than code creation. AI is now touching all phases of the software development lifecycle. It can help with everything from trying to capture and document initial requirements to gathering and making sense of analysis to, as we've talked about, code generation. We've got the development cycle there. So a lot of it is activities, as we said: generation, code writing, debugging, documentation, testing, and we'll come back to that in a moment. But interestingly enough, AI is more often now being used in CI pipelines to actually merge and deploy code, and also in production, right? So to maintain code. So we're using AI to actually help with performance monitoring and issue detection, and also remedy suggestion, and notably for AI assisted support as well, which can really reduce, certainly change the user experience, the customer experience of support, and can reduce the amount of resource that needs to be devoted to it. So the progression of AI driven development kind of looks like this, and we need to actually remember that we're still quite in the, a lot's happened, but we're in the early days of AI driven development. And this slide is trying to show you where we think we are. So to the left, you're seeing human initiated AI coding assistants that we're using to augment developers with code completion and code creation. And then we're sort of somewhere around points 3 and 4, where we're also using AI to change the way we automate certain processes in relation to programming and development. And those are, require interaction and quite a considerable amount of human oversight and supervision. And where we're trying to get to in terms of the maturity of our adoption of AI is to the right, which is, something that is actually more autonomous, AI-led, and will enable us to have intelligent and responsive automation. Whereas at the moment we're not quite there yet, but that's definitely the direction of travel, and it's changing the way, the role of the developer as well. Back in the day, a developer would primarily spend most of her or his time writing code. And debatably now, with the use of various AI assistants, we could look at our role changing from a code writer to more of an application orchestrator. We certainly feel that AI has the opportunity to augment, assist, and help developers. There's a lot of stuff out there about developers being replaced. Don't think we're anywhere near that yet, and we're not going to speak to that today. Certainly we're in the space of AI assisting developers with things that low value tasks that they don't necessarily want to do. And we have a vision of AI powered DevOps. If we recap what DevOps is actually about, DevOps is meant to enable faster, more reliable code deployment to production in ways that are optimized to be efficient and repeatable. But that's not where we are at the moment. And I'll just, Animesh, would you like to jump in now and talk about this?
Just one point here, yeah, because a lot of the people on the call will be familiar with and probably are already working in DevOps team. And the way we envisage AI affecting software development is enabling the kind of intelligent automation that you're talking about. So one of the most specific example would be currently we have these semi-automated testing. We call it automated testing, but it's a bit of a scam because the tests themselves still need to be written manually. So we have automated the running part of testing, whether that's end-to-end unit or others, but the writing of these test scripts is still a very painstaking manual process. So I would say that we are perhaps somewhere between 2 and 3 currently on the screen there, level 2 and 3. Where we want to be and where we are getting is very quickly we kind of leapfrogging 3 and 4 and getting all the way to 5 through some of the technologies we'll talk about today. But you take the part that you've already automated, which is running of the test. You take the part that can be automated using AI, which is writing of these tests. You bring them together, you get to automation that just works. You could write a piece of code, open a pull request, and then the whole thing comes and does the remaining work of writing the test, running it, identifying any gaps, fixing those, and pushing all of that to a PR so you can come and review it. And so your job in the development cycle then again transforms, and this is an evolution of DevOps from a person who is buried into the nitty-gritty to the person who is all of these intelligent agents going and doing work for them, and you as a human in the chain are then taking the call on which part of the machine output is good to go, production ready, and which part where you still need some human input. And that is how I think it's going to change how software developers spend quite a lot of their time. They'll be doing more time reviewing things rather than doing it themselves.
Thanks, Animash. And that brings us to some of the differences between some of the AI options that we have today. So we're all familiar with AI coding assistants. A lot of us use them in our IDE. And, but I'm sure no one will have failed to notice that there's been a lot of buzz and talk and stuff written this year. 2025 has been officially declared of the year of the AI agent, and so it's useful. We're not going to assume you got informed about this, but it's useful to just quickly recap some of the key differences, the distinctions between the two, which largely relate to the level of autonomy, decision making, learning capabilities, task complexity, and the interaction style, how much time the developer actually had to spend interacting with the product or solution to actually get the desired output. And, AI agents are very they're highly interactive. They help us originally with code completion, now with code writing, and with looking up information that will assist the writing generation of code. But essentially, what you get out from them is very dictated by your acumen when it comes to actually prompt engineering, your input, the developer's input into the AI assistant, and how much it actually understands not just the code base, but the actual supporting environment, the dependencies. And that's where AI assistants can be somewhat limited in terms of what they can do. They're really highly suited to simple, predefined tasks. And essentially, they don't require too much trust, because essentially the interaction is that a human is going to ask an AI system to do something and going to iterate and interact with it until get closer and closer to the desired output. So potentially they don't need to be 100% accurate, because there's an iteration cycle involved with getting to whatever the goal of is that you're using them for. Whereas AI agents are much better suited for complex multi-step tasks that require precision, and essentially they're autonomous, at least will require little or no input. That's where they need to be to actually qualify for being an AI agent. They're capable of autonomous decision making, capable of learning to improve the outcome. And the output has to be, if we are going to lean into this level of tooling, the output has to be correct. The only way that we can trust AI agents to and hand off tasks and processes to them is if to be so that they can autonomously operate is if the output is actually correct, if the output is something that we can trust and rely on. And certainly you'll probably have heard of agentic workflows. You have AI agents for single tasks, sorry, and then you have multi-agent workflows that are capable of completing multi-stage tasks with different specialties. So what's our barrier to adoption? How do we unlock the AI productivity potential? Not where we are today, but the now and the next and the future. And some of the barriers that exist today are a lack of trust in AI generated code, LLM-driven AI coding assistants that really account for about 98% of the share of voice when we are talking about AI for code tooling, but also in terms of our use. They don't scale very well. So we've already talked about their limitations in terms of what you get out is very dependent on what you put in. But essentially, they're very good at assisting individual developers, particularly in the development phase. But they're not great at this point in time at scaling across multiple teams. They can't be used to actually standardize our approaches to various development tasks, including test operations. That's where we are today. It's not to say that they won't evolve in a way that I haven't predicted, but that's one of the limitations today. And then in terms of automation, you might say, well, we've had automation for absolutely ages, but as Animesh did point out previously, we've kind of had semi-automation that is script-based automation, requires some oversight, but it's not fully autonomous and it's certainly not intelligent. So the way that we predominantly use AI for code tooling right now is in a way that really doesn't require an autonomous capability at all. And so we have the option to use those products, but as the cartoon shows, sometimes what we get back is not what we're intended. And then we have the option to either prompt again or to actually just do it yourself, DIY approach, which isn't very helpful. And this really has impacted on how much developers actually trust AI generated code. So again, this is the Dora report from 2024. And, essentially one of the key outputs of this report was that, by this report, only 39% of respondents reported, sorry, I'll turn that on its head. 39% of respondents reported that they have little to no trust in AI generated code. And what we're hearing from professional testers, for example, is sometimes they'll use them for AI assistants for certain AI coding tasks. But if you are actually an experienced tester, it's debatable at this moment whether, how far you can actually get with an AI assistant, or whether actually, if you're an experienced tester that knows the code base, that sometimes you're just better off actually writing your own test cases. That's not great because it's not really realizing the productivity potential. And certainly Stack Overflow did another developer survey, and it was essentially the same thing. 66% of professional developers, engineers, didn't trust AI generated code, or very little. So how are we going to shift to the right, as we've shown, to actually realize more intelligent use of AI and intelligent automation? The diff blue view is the future is agentic, but if we are going to make better use of AI for code, there are certain pillars, there are certain requirements, if you like, that AI solutions need to have. And that's what we're just showing you here on the slide. So we'll just speak to this for a second.
Um,
You, Agamish.
yeah, it's The best way to think about this is because agentic AI, there's a lot of talk about it, different people define it differently. Uh, when we say agentic, I want you to imagine an appliance. So any appliance that you might have in your home, right? All of those appliances that you use day in, day out, the reason you use them without giving it a second thought is because they exhibit all of these characteristics that you see on your screen. They are accurate. They do the task that you want them to do. They do it every day, exactly in the same manner, and they're predictable. So when you press the button, you know exactly what you're going to get from your coffee machine. It's not that on Monday when you press the button, you get your tea, and on Tuesday it starts putting out mocha, and on Wednesday you get the espresso that you were really after. And so that, because at the end of the day, the game is automation. AI is a means to get there. So we don't need to get too lost into the means. If we keep our eyes on the goal, which is to automate things in an intelligent fashion. And these pillars guide the way we think about building our product at DiffBlue. Every single step that we have taken, every single design decision that we have made, we have done so that we can provide a product that is as appliance-like as possible. Deterministic, so it's predictable, it's repeatable. Given the same piece of code, it will always write the same test. It is it is accurate because we use a model. We use a reinforcement learning model that runs completely locally and runs your code to understand what it does. Based on that understanding, predicts a unit test, finishes the unit test with every time it runs the test against your code, evaluates how that good that tested. So the first test it writes might not be that good, so then it will have another go and have another go and have another go and keep going 1,000 times a second until it reaches a unit test that delivers the best coverage in the fewest tests possible. So I would suggest it's a lot like starting off with a block of granite and then chiseling away until you get to your David. So we every single design decision we made in there was to make sure that DiffBlue as an AI agent can scale. So the fact that it's deterministic allows for an autonomous operation. There's no prompt to be had. There's no prompt engineering to be done, thankfully. You give it a piece of code, you click a button, or you run a command in the command line. It goes and does all the work for you. At the end of the process, what you get is a 100% production-ready unit test that will always work, exercise the code under test, and the assertions it has will reflect the runtime behavior of the code. And all of this works just as well on your laptop as a part of your IDE, and you can truly properly automate the automation by sticking it in your CI. A lot of our customers scale the value of DiffBlue across teams and organization by using it in the CI process. So the way that works is you can set up DiffBlue so that every time you come and open a pull request, DiffBlue will swoop in, look at the code chain submitted, and keep your test suite in sync for you. So then at code review, you would look at the code change, you would look at the test that DiffBlue has written. Those tests will describe how DiffBlue works, and that behavioral definition should then tell you whether the code change you've made is what you're after. So, and that key ergonomic design decision is what helps us differentiate from LLMs. One of the most powerful thing about LLMs is also their biggest weakness, and that is their customizability. Because they are so customizable, because they are so designed, because and that customizability comes from the probabilistic nature of these tools. You can shape them and you can torture them sometimes to get them to give you the answer you're after. The problem is your mate can't then just copy that and get the same answer. So that repeatability just completely breaks because of how customizable and how context specific they are. We work with customers who have, in the early days of LLMs last year, decided, okay, do you know what? We're going to go all in on prompt engineering. We're going to figure out the best kind of prompts that can write unit tests or end-to-end tests using Copilot. And they've spent an enormous energy into building these prompt libraries. But what they found was even the smallest of changes in the underlying model renders all of that work completely moot. So the the key thing to take away from this discussion, if you could take one thing away, was that LLMs aren't the only game in town. There are other ways to do AI to achieve the goal that is automation. And those other ways might have characteristics which allow them to be a lot more scalable and a lot more adoptable than these large language models that we're trying to fit into a very small on-prem systems. Back to you, Zane.
All right. Thanks a lot. So, I mean, just to round on all of that, you know, essentially those pillars have really underpinned how we've actually developed Diff Blue Cover, which is an AI agent for unit testing Java. And, you know, the key thing about Diff Blue Cover is that it not only writes the test, but it actually maintains the tests as the code changes. And between those two things, that really reduces down to single command the generation of tests each time rather than a prompt workflow. So I'm going to move on because, you know, it's all very well us talking about a lot of this. But essentially, we've also gone one step further, which is we've done very recently a control comparative study of Diff Blue Cover versus a leading AI assistant. Yes, you guessed it, it's GitHub Copilot. And what we've done is really used unit testing as the use case. And what we wanted to do with a control time-boxed study was to actually compare the performance of both products. And really, essentially, it's an AI assistant versus AI agent race to see which performs better when unit testing. So we time boxed the amount of time that we actually devoted to this. So both products were given the same amount of time to do the same tasks. We chose 3 indicative open source projects that were chosen for their complexity and, you know, their essentially how they mirror real world complex code bases. And essentially, we measured accuracy and reliability and some of the other pillars that we've talked about. And so I'm just going to take you through some of the results. Out of the box, one of the things our customers and our prospects talk to us about the most is achieving initial coverage gates. And so test coverage was one of the first things that we looked at. And out of the box, the autonomous agent, which in this case was Diff Blue Cover, was able to achieve 53% test coverage out of the box on the first run, and on the same code in the same amount of time, with an iterative AI assisted workflow. So a developer using an AI agent, we were only able to achieve 15% test coverage. Other things that matter in terms of, in addition to coverage, are things like test strength. We also took a look at the actual quality of the test output. If you take a look here, one of our key measures of this was if of the tests outputted, how many tests required or didn't require reworking by a human developer. And in the case of GitHub Copilot, 64% of the tests outputted didn't require rework, which basically means 44% of them did. That's almost 50%. Whereas Diff Blue Cover produced a test that would compile They ran as well as passed. They didn't require a human to actually validate and verify them. So that was also a key measure. And we've also got some other big stats to present to you, which is diff blue cover resulted in 4 times faster unit test case generation in the same amount of time. To achieve that 4x higher coverage, it wrote 10 times as many tests in the same amount of time as GitHub Copilot. And then if we look at the actual workflow to get to those results, diff blue cover as an AI agent, which did not need to be supervised and did not need iterations, resulted in a 26x productivity uplift. So essentially, diff blue cover, we were able to just point it at the code bases, and it was able to just from one command or one click to generate all of the test cases and test suites needed to thoroughly validate the code that was under test. So essentially, you know, diff blue's fully autonomous agent generates high quality tests, better quality tests, and can also generate tests for an entire project rather than a method or class level without developer intervention. And that really results in that dramatic 26x productivity uplift, as well as the very impressive test coverage statistics that we've just talked about. So a lot of these things are points of evaluation when looking at what's going to suit individual developers, but also what will suit a engineering team. And so to recap on some of the things that we've talked about, you know, we think these things are essential. These are the essential components of having a happy path to higher code quality at scale. And when we're talking about at scale, we mean not just an individual tooling that individual developers can use to actually help them create code. We're talking about scaling across multiple developers, across a development team, maybe more, to standardize the approach to testing. AI agents and assistants are both integral parts of the engineering landscape, but moving forwards to get to the next level, accuracy, predictability, and repeatability are crucial elements that are required towards intelligent automation. And essentially, this can only be achieved to the highest degree by AI agents that are autonomous and can carry out testing to a much higher degree of accuracy and reliability. And if you get to that point, we can actually lean on AI agents more fully. We can hand off entire tasks to them so that we can, as developers, focus on high value tasks that still require our input and that we're happy to do. And then AI agents are the way to really unlock true productivity gains, and also both at a team level, at a CI pipeline level, but also at an individual developer level to reduce the amount of repetitive toil and effort. And we feel that unit testing, because it's a foundational form of continuous testing, or at least if we want to aspire to continuous testing, it would definitely need to have a developer that is augmented by an AI tool that achieves those levels of accuracy, predictability, and repeatability to be able to rely on AI-driven testing more fully. So we talked about the study that we did. If you go on our website, you can follow the signposts and you can actually download the study, see the details, see the methodology behind what we did. We don't want you to believe what we say. By all means, be curious and go and have a look at what we did, and you can put the, what credibility or not on that. But we also wanted to just also signpost our next webinar. We've done a lot of talking today. Usually we do demos, and in our next webinar, we're actually going to revert back to doing a demo, and we're actually going to bring to life by doing a live comparison of Diff Blue Cover and GitHub Copilot for unit testing Java live on April the 2nd. So we really, really hope that you will join us for that. If you look out on the website or on LinkedIn, as of tomorrow, you will be able to sign up for that. And we really hope that you will join us for that. And again, with our product, we've told you about it, but really, we're engineers. You need to be curious and try it out for yourself. So the QR codes here will show you that cover is available for use in IntelliJ or advanced capabilities using CLI. And if you are interested in trying out the capabilities of test automation at scale in CI pipeline pre-merge, we also have deep integrations into GitLab CI and also GitHub Actions CI pipeline. So if you use any of those, you can use the QR code to get to the 14-day trial that will help you execute that. And if you need more time, reach out to the team and we'll be happy to assist with that trial extension. But I'd also like to say that we do work with other CI pipelines. So if they're not the ones you use, ask us and we'll tell you whether we support them. So not much more to say. It's really kind of over to you. We'd really appreciate it if you have any questions for us, if you could drop them into the chat, and we'll turn over to talking to you guys and answering any questions that we can. And while we're just waiting for some questions, I'd just like to ask you one myself, actually, Animesh, and I hope I don't catch you out here. But one of the limitations that we've pointed out with LLM-driven AI assistants is, that they lack awareness of the full context of the code base and its dependencies. And I've seen a lot written about RAG. I've seen a lot written about LLM tools being able to tap into, for example, real-time live data sets. Is that the answer? Or is that, are we still limited there, even if we've got AI assistants that can make use of RAG?
So the idea behind RAG is to augment the context that the LLM has with something that is closer to my own, right? Because these large language models have been trained on the universe, correct? So the idea is that maybe I can help them a bit more with my own specific concept and supply that as they're trying to process and produce a response. But the fundamental difficulty with any coding using LLMs is the large language models, they were not designed for this task. They've been repurposed to do this task, right? What they're really good at is natural language processing, right? Because that's what they were designed for, and that's what the transformers underneath are really good at. What they're not good at are looking at a natural language by design is murky. It's very context specific. It could mean the same sentence could mean three different things depending on the context. So they handle that really well. What they're not so good at are scenarios and contexts where meaning is exact. It is said in a specific manner and it needs to be replicated in that exact manner, which is why they struggle with mathematics. And that's also the reason why they struggle with code, because programming language are written in a very exact syntax. Because they don't have any underlying understanding of what that syntax means. So when an LLM is looking at a method, it doesn't really know what a method is. It doesn't really know how different methods are chained together. And because of that, there will be techniques, and there are techniques that people like Claude, for example, are successfully exploiting to get them to do better code. But it will never, I think it will take something fundamentally different underneath in the technology to get to a point where you can point a large language model driven application or an assistant to a piece of code and say, understand it, and then write code that works. Because and the reason for that is because they actually never run the code they write, and that critical feedback model is missing. So the way we write tests in DiffBlue, and the reason that reinforcement learning model is so important is, A, it allows us to finesse a test, so we can start off with a basic thing and just keep running and finessing it. But most importantly, every time we run it, that computational understanding that we gain when we run a test and it fails, or when we run a test it passes but doesn't give us much coverage, that is what allows us to then do better in the second iteration. Currently, the way the assistants work, that iteration is being done by a developer. So you write a prompt, you get something, you run it, it doesn't work, then you go back to fixing that prompt and making it better. I don't see how the LLMs get away from do a fundamental shift from here. They might just get better at doing the prompt, but you would still be doing that prompt. Have I answered your question?
Yeah, I think so. That's really good. Thank you. Again, I'll just throw it out there if anyone's got any questions, but I'm gonna take a look because we did a poll at the beginning of this, and it's amazing some of the results. 100% of you are using AI. So everyone, you know, it's very reflective. It's 100% of respondents tonight have said that they're using AI. And then the second question was, which of the following AI tools have you already heard of? So the ones that you've heard of the most, yeah, glad to see that DiffBlue is on the list. However, the ones that you've heard of the most are certainly Gemini, Google's what used to be Google Duet, GitHub Copilot, not surprisingly, ChatGPT, not surprisingly, Codium Windsurf Editor, Tab9, and JetBrains AI Assistant. So that one's kind of the new kid on the block, and sounds like quite a few of you are taking a look at how useful that is. In terms of question 3, that was all about, you know, which ones you're already using. So sorry, the former question was which ones have you heard about, and you're mostly using GitHub Copilot, ChatGPT, and Gemini from Google. They are the clear winners of what you're already using in your daily lives, development lives today. So thank you very much for that feedback. And then the fourth question was very much about which would you find most helpful for AI for code tools to do. So essentially, what do you want to use them for? And 79% of you said to write my unit test, so that's great because you're in the right place. 64% of you said to refactor your code. 64% also said to document code, so understandability, understand what's going on. And let's see, and 36% said to detect regressions. So that is something that DiffBlue Cover automates, and certainly that is a key part of what we're trying to do with unit testing. So pretty much all predictable there. And then the final question was, do you trust AI generated code? Obviously that was a key component of what we ran through. We ran through the sort of big surveys by Stack Overflow and Dora, and 71% of you tonight said that you somewhat trust AI for code. 14% of you said trust it a little, but only 7% of you said that you trust it a great deal. And I think that's very telling, but it's also reflective of the larger surveys, developer surveys that we covered. So thank you very much for feeding back. That's really insightful, and yeah, it really helps us to understand what your needs are, and in terms of some of the developer pains that you need to solve.
Yep.
So,
There were a couple of questions in the
yeah,
chat. They're largely focused on what kind of test DiffBlue writes and what languages do we support. Currently, we support Java and Kotlin only. On our roadmap, we have Python, C Sharp, but those will be coming no earlier than 2026. So this year, we're focused fully on Java and supporting as many Java frameworks we can before moving on to different tech stacks. In terms of the testing part of the testing pyramid that DiffBlue occupies, for now, we write unit tests only. We are looking at how we can expand into other parts of the pyramid, but currently, DiffBlue is an autonomous agent that writes unit test suites for your Java and Kotlin applications only.
thank you very much for that, Animesh. And it looks like we've come to the end of the road and to the end of the night. We don't seem to have any other questions for now. I'd just like to say we do have a community forum. If you go to diffblue.com, if you have any questions, please feel free to look for us, either of us, on LinkedIn, to look for DiffBlue as a company on LinkedIn. You can ask us questions there, or you can go straight to our developer forum. That's probably the best way to place to ask us questions, where you can actually connect directly with the product engineers that are actually working on DiffBlue. You have the opportunity to influence them, tell them what your paying is, and we will do our best to help you. So nothing much more to say, except for thank you so much for your interest in DiffBlue cover, but also in the subject of this webinar. Thanks very much for joining us this evening, or if it's your afternoon. We realize your time poor and your time is very precious, so we really thank you for tuning in. And also to everyone who's going to watch this on the replay, we hope you enjoy, and please jump into the forum if you have any subsequent questions. Thank you very much. Thank you, Animesh. And also behind the scenes, we have our colleague Lee, who works on production. So thank you very much for supporting us and making this happen. That's enough thank yous. I'm going to bid you all good night. Cheers.
Bye.